Now we're going to reset the fields. We give each team the exact same field setup so as to not bias it in any way. And I just want to point out, for those in the audience who can't see because of the angle, this goal right here, this is a yellow goal. That's a red goal. We have another red goal here, and a yellow goal in that corner. You'll also notice green and black objects on the walls. Those are barcodes provided to the team, so they can use that to map the playing field or explore it, because each barcode can see, if you're sitting at a barcode, you can see at least one other barcode. Okay, so next up, we have team number 4 with the robots 175.
My name is Sam Powers, and that's Corey Lee, and that's Jessica Ruprecht, and we're all freshmen. So we had basically no experience going into this. Our robot is named 175, and it was intended to be named 257 because that was the number of revisions we'd gone through. But we were all really tired, and the teammate who was to go give the name just totally forgot the number and made it 175. So our robot's now 175.
Yes, so we keep the lab open from noon to 10 most days, but a few nights ago we actually kept the lab staffed a little bit longer, and most teams elected to stay the entire night and work on their robot. They're very dedicated. We have many dedicated people working on the robots this year. Oh, and the robot has started. So, what is your robot's initial behavior?
Our robot starts off by wall following, going around to the right, and we have a camera on it that looks out to the left, and if it sees a ball, it should, we also got a point right now, if it sees the ball, it should turn towards the ball, and then hopefully return to the wall. We'll see.
So your vision code is working. If you look on the screen, we're seeing the world through your robot's eyes. Can you tell us a little bit about that?
Yeah, currently the robot's not moving. It's... Oops. I don't know. Is it going to start back up, guys? It has some stall code. Yeah, it's thinking about it. There we go. Oh, maybe. So our stall code is kind of iffy because the thing it's relying on, there we go, is a little slow. So a bunch of our mechanics wrote like the day before, including the thing that we're doing stall code with. So it has to wait kind of a long time to make sure that it's actually stopped.
So how are you detecting a stall?
We have quad-phase encoders on the wheels, meaning that as the wheel spins, it detects ticks that are on the wheel itself. But the chips are kind of buggy, so we didn't want to have it go backwards randomly while we're moving. So it should wait a little while and then back up. But I don't know, we'll see.
It looks like your left wheel is just spinning in the air. Will that mess up your stall code?
I don't. Oh, if both wheels are spinning, then yes, it will stop. Wait, is it? Yeah, I don't think this one's spinning. It started to try back up. I think the process there.
So I noticed that your camera, like your robot's not moving, but the picture on Botcline is changing. Can you talk about that?
Yeah. So the camera looks out to the left initially, and then when it sees the ball, it rotates to the ball. And if it loses the ball, at some point it starts to scan. And so it saw a ball at one point, and then it's now continuing to scan for balls, using the servo mechanism which we had to repair last night because it died.
Okay. Team 4 has decided to call it because it appears a robot is stuck on that pillar. But they did score 1 red ball. They got the concession, so they get 1 point. Congratulations, guys. Okay, next up, we are going to have Team 3, which is ironically chosen Team 4 as the name. We guarantee each team 5 minutes to calibrate, so as soon as they're done, we'll move on to the field. Yep, so Team 3's ready to go, and here's their representative.
Hi, my name is Ray. We're Team 3. Our robot's called the Juggernaut because it's kind of big, and it also tends to do whatever it wants. So,
Can break the walls.
sometimes.
Okay, we're having some minor field repairs. So right now, the robot is just waiting for the press of a button to make it go. But the program is running and ready to go. As you can see, we are connected to them using Blackline. Technical issues. Please hold. So, Maslab, this is our 9th competition, and it's evolved quite a lot throughout the years. When it was first run, there were a few teams, and they were given a task very similar to this one, but they didn't have quite the technology available to them. There were no gigahertz plus computers back then. And throughout the years, we've evolved, changed the game some, and we're making sure to keep each team updated with the best technology that we can give them. And that's due largely in part to our sponsors, which you can find a complete list on the back of your programs. But we do have heavy industry sponsoring, and primarily by ITA Software and the Sean Company.
But then again, have you actually seen it?
Okay, they're hoping it will work.
You get
It opened up a lot more options for teams. The first team that went, team number 1, they could only collect 1 color ball at a time. And
okay, you're going to attempt to run the robot. And start button's been hit. And the robot has started. What is the word that, some team, if you're in the front, you might be able to hear a word from it.
Yes.
What is that?
So we have a central conveyor belt. That's why it's so tall. Like it picks up balls from off the ground, brings it to the top, where we have a several power sorter there. And we have a photodiode set up so that it reads what color the ball is, and it shoots it to whichever side of the robot it should go on. And so that way, like, we're storing the balls within our robot. Of course, that's absolutely useless if the robot does not go anywhere. But in theory, it works perfectly. So use your imagination.
So you've decided that you want to be able to collect both color balls and sort them on the robot. What was your rationale behind that?
We figured more points, more risk, but higher reward, so whatever.
With the rule change this year, it's encouraged a lot, it's opened up a lot more options for teams. The first team that went, team number 1, they could only collect one color ball at a time. And as such, they could really only score either red balls in the red goals or yellow balls in the yellow goals. So for teams that have much more of a mechanical engineering background, such as it appears Team 30, how many of you guys are Mendees?
But we had a 416 too, so
16 is kind of small. 16 is Aerostro, and that is pretty much a Mendy, almost. As good as one.
False.
So...
Not true.
Oh, better.
False.
Okay, so Team 3 was mechanically inclined, so they decided to build a complex robot that could gather both color balls. So they're going for complex strategy, which it would be interesting to see if that worked out for them, but can't prove. Okay, so Team 3 was... Okay, so what is the symbol on the front of your robot?
that's our fraternity symbol. We're from a fraternity across the river. Schoolhouse. We were going to name our team Schoolhouse, but the edit didn't make it in time, so we apologize to Team 4. It wasn't really on purpose.
Right, you'll notice in the program that Team 3 has decided to call itself Team 4. Just to confuse everyone. So, where is your camera located? And I'm assuming you use vision code?
You can kind of see how vision code looks there. Everything's red, which is great. The camera's situated right in the middle. It's really hard to see. If you look at the picture, you can kind of see it. It sits right in the middle, in the center pretty much. Sort of the same for all the bots. But yeah.
What is this state information that you're printing?
You're going to have to ask someone else from our house in the audience about that. I'm not responsible for any of that.
So did your robot decide, how is your program designed? Are you doing a fine state machine or emergent behavior? How is your code modeled?
We're doing a state machine.
So, okay, they've decided to call it.